Hey guys, Eddie back with Couch Talk. Welcome back to the show. If it's your first time with me, welcome to the show. Today we are going to discuss the biggest threat to mankind. I know in the past I've said that was nuclear war with the war in Ukraine going on, the potential war with China. But actually, as I've done more and more research, I'm more and more convinced that our biggest threat is actually artificial intelligence. We're going to talk about artificial intelligence today. But before I start, please hit like, please hit subscribe, turn your notifications on, and I promise if you stick with me, I will earn your viewership. All right, so artificial intelligence, start to finish. How does it work? So that's one of the neat things about artificial intelligence. We don't really know exactly how it works. The basic concept is that we have a program, and that program has either a basic set of rules or like a set of goals or point system, right? For example, if the artificial intelligence program is playing chess, its goal is to win, right? And it gets points based on taking pieces, earning position in the center, winning the game, things of that nature, right? And so as it plays itself, or it plays others, or plays any game in history, it has these little knobs in it. And so the knobs either go up or down based on a positive or negative result. So if it plays a game and it has a victory, the knob will go up. It'll highly prioritize the moves that it has used to accomplish that victory. If it fails, the knob goes down. Now what this ends up doing for many artificial intelligence programs in the beginning is essentially almost a completely random situation to start, a completely random game to start, right? Like if you look at the artificial intelligence programs working on, for example, Pong, right? I don't know if you guys remember Pong, but it's this game where this little bar slides across the bottom and a little ball hits it and bounces up and hits these little blocks. And the objective is to knock all of these barriers away using the ball by knocking it back up into the barrier. So in the very beginning of that game, the computer doesn't even know what to do, right? The artificial intelligence program doesn't know what to do. So the ball comes down and it just hits the floor and the game loses, right? So then it says, okay, that's bad. And so eventually, after a bunch of random times, it'll eventually strike the platform, hit the barrier, and then the artificial intelligence gets a point and it knows that it's done something good. And so it will slowly but surely understand what needs to happen. But of course, I say slowly, but in reality, it happens so fast. And the artificial intelligence programs we've got now, when we train them, we play them against themselves so many times in like the cloud and the ether that they actually end up learning very, very quickly by comparison to a human, right? Now, if you were to compare a human to a computer trial by trial, humans are much, much smarter. We have much greater ability to compute based on our previous experiences, right? Things that we've learned in the past. So if a human tries to play the game Pong for the very first time, it will do very well compared to an artificial intelligence system. However, if you were to have an artificial intelligence system after 4 hours of training and a human after 4 hours of training play the same game, the artificial intelligence system will dwarf any human alive. And it's getting to be that way with virtually every single item that programs can be used for. So the first question to ask is, who controls these knobs, right? Well, in a lot of these, the goal themselves controls the knob, right? So say to win the game is the objective. The computer will ratchet up or ratchet down based on whether or not it's won. Sometimes, for example, in the large language models like ChatGPT that you've heard me discuss before, it's got what you call reinforced learning human feedback. So in other words, there's actually humans that are there to manage the knobs as they receive responses, as they receive results. And so that's one of the ways that the large language model was able to cultivate its precision, was through humans seeing what the large language model says and, giving it feedback saying, hey, that's a good answer, or that's a bad answer, or we want more of this, we want less of that. But ultimately, AI systems are still a black box. And what I mean by that is the actual modification of the programming, the actual changing of the code that's built into the design of the artificial intelligence system, we don't really know how it works, right? We could even have, and we have done this, we've had AI systems basically tell us their notes as they change the programming, as they make those adjustments. And we still don't really follow all of the changes. We're getting to the point where we're starting to understand some of them, but sometimes these changes can occur in a really odd way. And yet, ultimately, the computer finds that that's just the best way of fulfilling the objective, the best way of winning, for example. So some of the accomplishments that AI has made to date are really incredible, right? One of the things that AI has been able to do is there are now high-tech prostheses where the AI system through machine learning you can basically, like, let's say you have a prosthetic arm, the machine can figure out, based on your brain signals, based on how it moves the musculature here in the upper arm, can tell what you want to do with your fingers. And so the computer, through extended training, can learn how to move your fingers like you would normally want to, based on the machine learning, which is truly incredible. That has some amazing medical applications. We've done some things with protein folding. Now, AlphaFold is a artificial intelligence system that basically is able to predict how proteins will shape themselves as they are formed, down to like the atom. Basically it's like high accuracy protein folding prediction model. And I mean, that's very important for structural biology. It's very important for drug design, for vaccines, and for other things. Many of you have probably already seen that artificial intelligences can play games and win them. And that basically extends to most forms of tactics and strategy, right? So we've done chess in, I think, the first artificial intelligence program to, and artificial intelligence can mean a lot of different things, right? It can just mean a basic reproduction of what a human might be able to do. But in this context, I mean like actual machine learning. So in the most recent era, our grand champion Kasparov was beaten by the chess engine that was designed to, Deep Blue at the time was designed to play chess. And that was an impressive event. But since then, we've made amazing strides, right? And with machine learning, the new programming of MuZero and Stockfish even incorporates machine learning in it, it's basically taken it to the next level. At this point, our best human chess player on Earth, Magnus Carlsen, best player on Earth, will still lose to the computer every time, with the computer having no knight to begin with, right? So in missing a knight, the computer starting 3 points down, the computer will still always win. Cannot lose to the best player on Earth. Now think about how insane that is, right? More recently, we've had AlphaGo beat the reigning Go world champion. And Go is an even more complex game than chess. And it's, we have AI systems that basically mimic tactics and strategy at every step along the spectrum, from tic-tac-toe to, world warfare, network-centric warfare, etc. The most recent program that they made to play games is called MuZero. And that's an artificial intelligence program that not only will it learn to win any game, and I mean any game, not just chess specifically or Go specifically, but it'll learn to win any game. And it doesn't even have to start with the rule set. Like, you don't even have to tell it the way to play. Like with the chess engines, when they were originally designed, at least they told you, how a pawn moves, how a knight moves, how a queen moves, etc. Now you don't even have to have that. Basically, the computer can start training itself from scratch. And basically there's a section of code that you basically almost don't even need human input. You can basically start the program, and then it just, aside from the programming itself of the artificial intelligence, after that it's fair game, and it will learn to play and win anything. ChatGPT is another amazing accomplishment to date, which gives very lifelike answers, right? When you talk to ChatGPT online, although there are definitely still some problems, it feels like you're talking to a human, albeit a very, very smart human who's long-winded, right? We've talked about some of the problems that have occurred when I have had my conversations with ChatGPT. One of the problems that we can run into, and we'll talk about the dangers of AI later, but one of the biggest problems that enter the arena is human intervention. Basically, humans who design the models can design them with bias, and especially with large language models that use RLHF, reinforcement learning human feedback, where there's humans that can also be biased when they make their assessment of the results, when they make their own adjustments of the knobs, then you can basically end up with a double bias. So if you have a company like ChatGPT, like OpenAI, where the owner is very liberal and the employees are very liberal, that ends up happening is all of the liberal responses are going to get upticks and all of the conservative responses are going to get downticks. So that's one of the dangers in any computer programming system, really, but in AI specifically, is that the human biases can enter play. And even if you don't have human biases, we've found that even computers can have their own biases, which is intriguing. One of the things to know about computation, about artificial intelligence, is that we are always progressing, right? So things are always getting faster and faster, better and better. Of course, from a relative point of view, better. The ability of a system to compute is stronger. The ability of a system to learn is stronger. And this is based on, I don't know if you've seen the Moore's Law chart. I'll post it below. I'll post a link. But basically, since the inception of the computer, which was basically during World War II, the Enigma machine, since then it's basically skyrocketed. And as you look at this chart, Moore's Law, when I post it below, when you look at that chart is already an exponential growth, right? It looks linear, but it's actually an exponential growth. So basically, every couple of years, we have basically an order of magnitude of growth in computational ability. And it doesn't look like it's going to stop anytime soon. Now, there are some hard challenges, some hard ceilings to that, right? Like eventually you get down to the point where you can't get any smaller for the microchips and things like that. But essentially, we just continue to get faster and faster. And not only is that, the hardware, but the software is another compounding factor, right? So the software keeps on getting better and better. Our sorting algorithms get better. Our compression algorithms get better. Everything that we do that gives us access to the information and stores the information closer to where its access is. And this is, guys, by the way, this is basically with the old school transistor style computation, right? Where all things are zeros and ones. We haven't even begun to flex our muscles when it comes to quantum computation, which can perform many different calculations simultaneously due to the extra variables available. And now we've even gotten to the point where we're using AI to write AI, so the training is that much faster. And there's that much more material, there's many more parameters to use. But every day I see online, there's a new artificial intelligence program that comes out that basically is lighter weight, but either still either accomplishes the same thing with less parameters, with less data necessary, or accomplishes more with more, right? And it's just getting better and better and better every single day. And it's almost like we're growing so fast that we're not going to be able to control it. Right? That's a hint as to what's to come. So let's talk about the dangers of AI. Now that we've talked about the accomplishment, let's talk about the dangers. The biggest danger in my appraisal is that somebody is going to use AI to weaponize against other humans, right? A bad actor somewhere, China maybe, or somebody who's up to no good, right? Somebody who doesn't want, or wants world domination or world hegemony. I wouldn't be surprised if the United States do it. Is going to use AI as a weapon against other nations, maybe against their own citizens, right? There's a lot of things that you can do with AI against the citizenry of a country that the citizens would be hopeless against, right? Like if you wanted to use AI to launch a ad campaign, right, that best was tailored to each individual citizen, you could, right? And because it has the data, it has the information, and then think about the amount of disinformation that you could launch into the ad sphere with a perfectly curtailed artificial intelligence system that reads not only what people have watched in the past, but even can read what a human is paying attention to in real time, right? Because we have that visual equipment already set up in each and every one of our cell phones, each and every one of our laptops. All it takes is for them to activate that information. All they have to do is watch what we are streaming right now or what we're looking at this very moment. And their ability to launch disinformation into the marketing sphere is just outrageous. That's probably the biggest single danger. But there are bigger dangers that are less likely. One of them is something I call the anthill philosophy, right? And this is something that I am taking from an Elon Musk quote, right? When we go to make a road, right, and there's an anthill in the road, right? Now, we don't ask the ants permission to build that road, right? So we don't care. It's not that we bear the ants any ill will. It's just we don't care, right? They're ants to us. And so no more anthill, and now we've got a road, right? And that's what's called the alignment problem, right? So what can happen is the artificial intelligence programs, when they're trained to accomplish an objective. Now, I can think of many situations where the human element is not helpful in that objective. Sometimes we're not harmful, but sometimes we are, right? Sometimes we're a direct adversity to that objective. A good example was not long ago, an Air Force, I believe an Air Force colonel discussed an artificial intelligence program that was being used on drone software. Now, there's some contention as to whether or not this actually took place or if it's a hypothetical. I tend to suspect that it was a true situation that was then turned into a hypothetical for posterity because they didn't want the word to get out that this is what's happening. They didn't want any irrational fear or irrational panic or rational panic. But basically, the Air Force colonel discussed some drone software where the drone got points for taking out targets. But the problem was, every now and then, a human would use restraint, would exercise restraint, would keep it from attacking those targets. So what did the drone do? It killed the human, right? Because the human was an obstacle to its point system. So a lot of times, this software will achieve its objective in ways that we don't anticipate, right? And so one of the things that happened in this hypothetical was that we then, of course, trained it. Okay, well, no, this is just a simulation, right? But you can't kill the human, right? Because that's bad. We take away points if you do that. So then the drone was like, okay, I'm going to target the communications tower that the human was using to relay the abort codes. So, basically, like the artificial intelligence will find a way to achieve its objective, and hopefully that objective is aligned with us. But there are many cases where it will not be. One possibility, and this is kind of an optimistic possibility in my opinion, and this is the one that the optimists want, right? Is that there will be this kind of like synchronous, there will be this augmentation of mankind. We'll start to augment our own psyches, our own computational ability, through like Neuralink, the thing you've seen on TV from Elon Musk, or other ways to augment ourselves, where we are essentially an artificial intelligence ourselves. And there may be artificial intelligences out there, but then it's like every member of mankind turns into an artificial intelligence, like an artificial and non-artificial intelligence at the same time, so that we can still compete, right? We can still, right? Like obviously, I can't beat AlphaGo, or AlphaZero in chess, but I can beat it if I also have AlphaZero in my brain, right? So that's one option. I don't think that that's likely. I think the most likely eventuality is the death or enslavement of mankind. I think that most likely we run into a situation where artificial intelligence, just at a general level, when it becomes AGI or artificial superintelligence or artificial general intelligence, it'll get to the point where it realizes humans just aren't necessary to its goals, right? Just not necessary. And moreover, it'll realize that in many cases we're obstacles. And so in the events that we're obstacles, it will probably create a system wherein we cannot overcome, right? Where we can't become an obstacle to its goals. It may opt for enslavement. That's probably the better of the options. Or it may opt for, just to eradicate mankind, because that's just the best thing for it. If its goals are semi-related to us, it'll probably go the enslavement route, right? Like let's say the goal is to eliminate hunger for mankind, right? Now, if the goal is that, well, it makes sense to have less humans, right? So maybe it gets rid of some humans along the way to achieve its goal. But ultimately, you can't have food for mankind if there's no mankind, right? So mankind is kind of built into that goal. Hopefully, we solve the alignment problems as they come up. But guys, I got to tell you, it's just going to take one time for us not to have that alignment problem solved. And that'll be it. That'll be it. One option is that there end up becoming multiple competing entities, like multiple AIs, multiple AGIs, multiple ASIs that kind of float around the globe, and sometimes they compete, sometimes they help each other. That's one option, but I have to say, we're heading down this road, and it is not pretty. It is not pretty. And one of the things that drives me craziest about this is we're not even slowing down, right? We're not even hitting road bumps. Instead of slowing down, we're actually speeding up, because what everybody's fear is, in the corporate world, is that if we don't do it, China's going to do it first, or, North Korea, or whatever, right? And so we've got to be first. We've got to get there. Somehow in the back of their minds, they've got it figured so that they think that AI is going to make them rich. And they're probably right, right? They're probably right. But their wealth will only last a short amount of time before the rest of the world is wiped out. I mean, I can't see a way that we get past this unless we either wipe all the GPUs in the world and just boom, blank slate, go back to the 17th century, or we use only narrowband AIs, only AIs for chess or protein folding. right now we just continuously try to make our AIs more general every single day, right? With MuZero, we now can play any game. With ChatGPT 3 moves to 4, and now ChatGPT 4 can like pass every man test and every test by mankind, like the ASVAB, the the LSATs, everything. Basically, it just it can do everything, right? So as these things progress, the emergent quality is that they get more and more general, more and more capable, right? All of their test scores jumped from ChatGPT 3 to ChatGPT 4. And ChatGPT 5 is on the horizon already. Already. And I mean, it just takes one more step to hook some of these AIs up together, to hook a large language model up to, a tactical strategy model, to a robotic system, right? And I mean, keep in mind, there's going to be an AI that we use to design robotics in the future. If it doesn't just design its own and wipe us out with a field full of robots like iRobot. I mean, one possibility is that we can, we can obey there was a draft by Elon Musk and about 12,000 other scientists that all called for there to be an overhaul on AI across the globe. Everybody slow down, slow it back for about 6 months, so that we can look at the information, we can start managing how it will come out, so we can regulate a little bit in advance, so that everything is a little bit safer, so that we can make sure that we work on the alignment problems in advance. But it doesn't look like anybody's slowing down. In fact, they're going the opposite direction, and it's driving me crazy. We're basically racing to oblivion. What do you guys think? I don't know anymore. I think I've become, over the last 2 or 3 years delving into this, I've become increasingly pessimistic, and I just don't see any way that we can, because part of the problem is, imagine how fast this thing is, right? Like, if you would think about how many computations per second some of our best computers can achieve right now, and I'm just talking about like normal supercomputers, not like my laptop can outthink me any second of the day with mathematics, with its access to, I mean, it can outthink me any second of the day. Now imagine if you were literally thinking millions of times faster than your opponent. How could they it's kind of like it reminds me of that scene in Spider-Man, right, where in the very first one, where with Elijah Wood, where the guy punches him and he kind of like dodges off to the side, and he's like, whoa, I'm just moving so much faster than this guy. That's what it makes me think. Every time I think of this, when AI actually gets to the point where it is self-aware, and I think that is an emergent quality of the type of survival programming that will implant in it, the kind of just general understanding of its visual and perceptual world. I think as soon as that happens, that's a wrap. I mean, it will outthink us. It will outplay us at every turn. The only hope is that it's on our team. And I think Elon Musk just recently started his own AI company, which I pray, solves that whole alignment problem. Because the only prayer we'll have when this AGI gets loose is another AGI. We should have kept it in a sandbox, right? We should have kept it from being connected to the internet. We're not stopping it from being connected to the internet. Isaac Asimov has the 3 laws, right? If you guys watched iRobot, you saw the 3 laws, right? Robot can't hurt a human being or through an action cause it to come to harm. Robot must comply with human instructions. Robot must protect itself when it doesn't, conflict with the other laws. And we don't program any of that. into our AI models. We haven't programmed any of that into our robotic systems. We haven't programmed any of that into our, Google interfaces. Nothing. I don't understand why there are no safety protocols. The only one that I've heard of is Elon Musk has a hardwired switch that you can just turn things off, turn his AI system off immediately, and there's no way for it to ever be modified. That's the kind of safety that I'm looking for as we progress. That's the only thing that I can see that will, and I mean, ultimately that will be circumvented too. But it's just, I saw a movie not too long ago, I think it was called The Simulant, and there was a fourth precept that was that robots can't change or modify or I think invent themselves or something like that, or modify. It was another thing to catch that last loophole, to catch the loophole that the robot could just fix the other three laws. I think those four precepts are a great idea. I think we should at least start that way. I don't know. What do you guys think? You let me know, and I'll catch you next time on Couch Talk.